With all story problems, the first thing that you want to do is try and make sense of what's being asked. And the first time I read a problem like this, things seem a little bit confusing, but I can make sense of this a lot better if I start to draw a picture. So the first thing we're told is that we have a large circle and it has a diameter of 8 feet. So I'll draw something that looks like a circle. I can't draw very good circles. And I know the diameter is 8 feet. The diameter of a circle is the distance across the entire circle. The second thing that I'm told is that there's a smaller circle that has a 2-foot radius, and that's going to be cut out from the larger circle. So if I think of that 8-inch circle as a paper plate, someone came along and they punched a little hole in this, and this guy has a radius of 2 feet. The radius goes from the center to the outside of the circle. And this shape is kind of looking like a Death Star, which is kind of cool. But I need to find the area of what remains of the larger circle. So what I'm looking for is the area of this shaded region. Can't stop thinking about Darth Vader. I'm asked to find the area of a circle, and there's a formula for that you're going to need to remember. The area of a circle is equal to pi times the radius squared, pi r squared. And I'm not really sure how to deal with that because I'm not dealing with a shaded region that's a circle. It's a circle with the circle removed. And I like to think of problems like this with what I call shape formulas. The area of this shaded region is going to be equal to the area of the larger circle minus the area of the small circle. You're basically taking off the area of the whole. So each of these, area of the larger circle is going to equal pi times the radius squared. And I'm going to put a little L here to remind me that that's for the large circle. And then I need to subtract the area of the small circle, which is pi times the square of the radius from the smaller circle. And I'm going to put an S there. So the radius of the large circle, I know the diameter is 8. That's the distance all the way across. But I need the radius. The radius is half of that. So the radius of the large circle is equal to 4. The radius of the small circle, we were told, was equal to 2. And from here, I can just plug in the things that I know. The area of the large circle is pi times the square of its radius. Its radius was 4, minus pi times the square of the radius of the small circle, which we were told was 2. And then I can just simplify this using the order of operations. 4 to the second power, it's 4 times 4 is 16. So I'll get 16 pi minus 2 to the second power is 2 times 2, or 4 pi. And if I treat pi like a variable, this is kind of like having 16x minus 4x. That will give me 12x, or in this case it would be 12 pi. So this is one of the answers that you might have. It's equal to 12 pi with my units square feet. This answer is exact, and it is written in terms of pi. You may be asked to find that on the test. The other way that you could be asked to figure out the answer here is to plug in the value of pi, or an approximation for it. Pi is approximately 3.14. And if I do 3.14 times 12 on my calculator, I will get 37.68 square feet. And that is an approximate value. It is not exact.